Cool thing about today. We are sort of nearing the halfway point of quarter four. So we really are getting down into the sort of last leg of school. And since we haven't met in a while, I'm just gonna take us through Schoology and just recap some stuff that we've done. So again, make sure we're looking at the pacing guide. Okay, if you're having trouble or you're not sure what to do, again, this is going to be your friend. It's going to help you. Yes, mid quarter is coming up. Okay, you can still turn stuff in after the mid quarter for my class. Again, it may be different in other classes, but for my class, it's okay. I want you to get that missing work turned in. And you can see that this was a really big week. Okay, we finished up unit 11, so we've been working on proofs. And I just, again, keep in mind that proofs are very difficult. Okay. I know that proofs are hard. They require sort of a big picture, a full view of geometry. And so if we, don't have that complete sort of view or understanding, it can be sort of difficult to know kind of what's going on. Now, I'm going to kind of run through a couple maybe tricks, or I'm going to run through some examples of very common proofs that happen. Because what you'll notice is in geometry, a lot of what we do is repetitive. We're applying the same ideas over and over and over again, um, just in slightly different ways. So we've been working through quite a different proofs. We did triangle congruence proofs, which again, there are 5 ways to prove that triangles are congruent. I'm looking for a volunteer. What are the 5 ways to prove triangles are congruent? Side angle side, side, hypotenuse leg, angle side angle, and angle side. Awesome job. Those are our 5 ways to prove triangles are congruent. Now, great point, Connor. Once we get a triangle to be proven congruent, think about that word congruent. Congruent means that every single line, every single angle is going to be the same. So, with that being said, if I prove using side angle side, or if I prove using hypotenuse leg that these triangles are the same, all parts of those triangles also have to be the same. And what is the way that we prove all parts of the triangle are the same? It is, like we've got in the chat, CPCTC. And I'm going to say this slowly. CPCTC stands for corresponding parts of congruent triangles are congruent. So if I can prove the triangles are congruent, I can prove all the angles, all the sides are also the same. So I'm going to run through a couple examples, and this is coming from the Proof Palooza extra credit. So if you look in this week, again, there are extra credit opportunities because I do want you to try certain types of problems. So the one that I'm going to do right now is number 5. And maybe I can share my screen. Again, if you've got something to write this down with, jot it down, that would be a good idea. So what are we given? Y is the midpoint of UK. What are we given? Y is the midpoint of TR. So first thing I got to do, again, my detectiveness, I got to decide, all right, if I know that it's a midpoint, They told me it's a midpoint. Well, then I can determine things about those. So I'm going to flip over to my notebook and share my screen that way. I was not sharing my screen. Were you able to see this? Again, this is the problem that we're doing. Y is the midpoint of UK. Y is the midpoint of TR. I'm going to draw it on mine right now, and then we'll flip over. U, T, Y, K, R. All right. So first thing that's given to me, and again, everything we got to do involves our statements and our reasons. So the statement, Y is midpoint of the segment UK, is given to me in the directions. I know that this is true because it's given to me in the directions. Y is midpoint of TR. I know because it's given to me in the directions. So let's start doctoring our shape up. I strongly recommend you mark these figures up, you write all over them, because that's what's going to help you, move forward. So first thing I know is if the Y is the midpoint, that's going to cut it in half. It's going to cut it in half and make it equal. So this is going to be equal to this. And that's because of, so I'm going to say UY is congruent to KY, and that's due to the definition of a midpoint. It told me they're midpoints. By definition, a midpoint creates two equal segments. Well, it also said that Y is the midpoint of TR, which means TY is going to be congruent to RY. So I'm going to say segment TY is congruent to segment RY by the exact same thing, by the definition of a midpoint. Okay. And so again, what am I missing? Right now I've got two sides. So if I think of my 5 triangle theories, side, 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 angle, side, side, angle, angle, side, and hypotenuse leg. I don't have a right angle, hypotenuse leg is out. I don't know 2 angles yet. Let's not think about these 2. So now I've narrowed down my options to 2 things. Can I prove this side is congruent to this side? Or can I prove that my angle that's sandwiched in the middle, this angle, is going to be congruent to this angle? And that's the route I'm going to take. And again, this is a blast from the past, but we talked about vertical angles all year long. Vertical angles occur right here, and vertical angles are always congruent. So I could fill out and I could say angle U, Y, T is congruent to angle, let's say K, Y, R by the vertical angles theorem, VAT. And once I do that, I now have a side. Let's get a different color. I've got side, angle, side, side, angle, side. I'm good. So I'm going to mark my proof up, and I'm going to say triangle U T Y is congruent to triangle K R Y by the side angle side theorem. However, the question said prove UT is congruent to KR. I haven't done that yet. How do I do that? I have to use that last idea and say that, yes, this is true because of CPCTC. corresponding parts of congruent triangles are congruent. So when I look back at the question said, prove UT is congruent to KR. I was able to do that through side angle side and then CPCTC. All right, that's one way. Another really common way is, again, something we've used before, segment addition, adding up angle addition, adding up little plus little to equal the big angle or the big segment. Okay, then we sort of jumped into our circles unit. Now, again, let's look at big picture, okay? Proofs can be hard, right? When we start getting into circles, and if we just sort of look at, we've kind of got some smaller units coming up. Again, circles is 3 weeks, surface area and volume is 2 weeks. They're the circles unit, I find students often do pretty well on. So again, I know that proofs are hard. Keep plugging away, keep trying. I really like circles. They have a lot of rules that students like to be able to follow. So let's just review those, and then I'm going to give you some time to practice with circles. So big idea is we've got something called chords now. Chords touch two parts of the circle but don't go through the middle. And a secant line is very similar. A secant line touches twice. A tangent line touches once. Tangent lines create right angles. And so again, we can sort of, because we know things like, hey, this is a radius, right? A radius is the same no matter where it is. So if this part's 12, well, this part's also going to be 12 because it's the same radius. So again, using what we know about circles to kind of figure out how to solve what we don't know. Here's another theorem with tangents. Again, if you know their tangent, they have to meet at a 90-degree angle. Arc measures. Arc measures, it takes 360 degrees to get all the way around. And when we have something called the central angle, so this right here, angle C, is our central angle, that's going to equal the exact same thing. So our arc is exactly the same thing as the central angle. Now that's pretty easy to remember, right? Minor arcs have 2 letters and they're under 180 degrees. Major arcs have 3 letters and they are over 180 degrees. Okay, and then sort of the last topic for this week, and again, I know this is a lot. These are properties of chords, which again basically say, hey, if I know that these two segments inside of my circle are the same, well, then their arc measures are going to be the same as well. Their angles are going to be the same because they're going to take up the same amount of my circle. Similar to what we talked about, chords, if they meet at a right angle to the center, then we know that this little segment here is also congruent. So again, I'm looking at FE and GE. If I know that my chords meet at a right angle to the center, then those segments have to be equal. And you can kind of see that right here. Okay. Let's do some practice. Let me get it pulled up here. We're doing okay for time. That took a little bit, but like I said, we had a lot to review. We haven't met in a long time. So I'm going to post a link in the chat. Please click. I lost you guys. Please click that link that I'm going to post and we will get started. Gotta turn that off. Mute. All right, I'm going to share my screen for those watching the recording. That way you can see the problems. Pause, try on your own, and then continue the problem. In this segment, these two are going to be equal to each other. So this segment here is equal to this segment here. Again, this is a right angle. So I would use Pythagorean's theorem. Side squared plus side squared equals hypotenuse squared. All right, we've got 12 people in the meeting. Let's see. We have 12 people. We've got 11. We're close. We're missing one person. Let's say about 90 more seconds, okay? 90 more seconds of individual practice. It's not letting you in. We're gonna move on in a second, okay? Okay, go ahead, finish up the problem that you're on. There's one that I want to review, and two that we hadn't quite learned yet, so that's totally okay, and that would explain why, we maybe didn't get as many of those correct. All right, I wanted to go over number 8. Sharing screen. Use chords to solve for x. So again, I know because it's a right angle that these are congruent. These also are going to be congruent. However, this segment right here is only 3, which means that this segment is also 3. So 3 plus 3 gives me 6, which means this whole segment that x is showing is going to be 6. Okay, let's take a look at your Class Connect assignment. And how do you find it? Because I know it's been a while. Okay, it's going to be right here in Q4 Class Connect assignments folder. It's the only thing in here right now. We did this problem together. Again, which way can you use to prove this to be true? And what did we use to prove that these angles were congruent to each other? We used a specific property or a theorem. And then tell me about these things, okay? What's the red line? What's the blue line? The green arc is A, the yellow arc is A. How many degrees is the pink arc? What is minor arc CD? Okay. These are things, these are properties that we've talked about and we've reviewed. So I want you to go through, it's drag and drop. Go ahead, pick out what's a tangent line? What's a secant line? What's a minor arc, major arc? How many degrees? That is your Class Connect assignment. So again, just to review, big picture, 10,000 foot bird's eye view. We've got our circles, and then we start perimeter and area, surface area and volume. We're not going to have a final exam. Okay. So basically, the second to last week of school, you're going to learn everything. The last week of school, you're going to review and take the Unit 14 test. So we do not have a final exam in geometry. That's the same as first semester. Okay. We did not have a final exam first semester either. All we're doing right now, we're finishing up unit 11 and starting unit 12. And then we're going to do 12, 13, and 14. So again, lots of good stuff going on. Keep working hard. We're about halfway through the quarter. Yes, you can still turn in work after the mid quarter. All right. Have a great rest of your day. That's all I've got for everybody. Make sure you get that Class Connect assignment turned in so that you can earn credit.